Hello everyone. Today we shall be discussing on how to calculate or determine centroid of a given shape. Once again, today we shall be discussing on how to calculate the centroid of a given flat rectangular plate given in this figure. Here we have a flat rectangular shape shown in the figure, which is 100 millimeter long by 30 millimeter wide and has two 12 millimeter diameter holes. Drill in it. Then we are requested to find the position of the centroid relative to the lower left hand corner. Lower left hand corner, which becomes our datum position. That is where our reference. So we are asked to calculate or find or determine the position of the centroid relative to the lower left hand corner position. Now, here we have a rectangular plate given. We have two holes drilled, which are 12 millimeter in diameters. We have its length, which equals 100 millimeters. We have its width, which is its breadth, which equals 30 millimeters. Now, to calculate the centroid relative to from its left hand corner, which is situated here, whereby we have our x-axis towards this place and our y-axis upward. Now, to calculate this area of the rectangle, we have A1, which is the first area of the rectangle, A1, which equals 100, that is the length times its breadth, 100 millimeter times 30 millimeter, which gives us 3,000 millimeters squared. From here, we calculate our x reference, which is horizontal reference center, which equals the half of the length, which is 50 millimeter. Also, we calculate the center reference vertically from here, which gives us 15 millimeter. Then we calculate the first circle area, which is pi r squared, and we are given that our radius, the diameter, is 12 millimeter. Then our radius will be 6 millimeter, which gives us pi r squared, which gives us pi 6 raised to power 2. By the time we put it in the calculator, we have 103.1 millimeter. Then we are supposed to subtract it from the reference because it's a drill hole. For the father, it's a drill hole. It has to be subtracted. So that's why we have negative. Then we now move on to our center reference from the horizontal. From the horizontal, we can see that from the x reference here, it will be 20. The center of the first circle to our reference point on the left corner equals 20 meter. Then we have 20 millimeter. Also, from the vertical references of the center of the first drill hole, we can see that it's 20 millimeter. Then we have 20 millimeter. Also, our second circle, likewise. For the father, we have the same area. Then our second circle area equals the same, minus 113.1 millimeter. Also, our horizontal center reference from the second circle equals 50 meter, while our vertical reference center equals 20 millimeter. So therefore, we will calculate and add all the area, that is the area of the rectangle plus the area of the first circle plus the area of the second circle, which gives us 277.38 millimeter squared. Also, we'll find the product of the area and the references of the two shapes, of the three shapes, which is the rectangle and the two circles, will give us A1 multiplied by x1 plus A2 multiplied by x2 plus A3 multiplied by x3, which entirely give us 300 multiplied by 50 minus 103.1 multiplied by 20 minus 113.1 multiplied by 50, all over the area, equivalent area of all our shapes over here, will give us 2773.1. Now, our SG, which is our horizontal component center of gravity, it becomes SG, it gives us 51.2 millimeter. Now, to calculate our vertical center reference of center of gravity, which is AYG, we will multiply and add the summation of all the areas with their vertical references, which equals A1 multiplied by Y1 plus A2 multiplied by Y2 plus A3 multiplied by Y3, which gives us our YG, which equals 3,000 multiplied by 15 minus 113.1 multiplied by 20 minus 113.1 multiplied by 20, all over our area, which is 2773.8. Then our YG will equals 14.6 millimeter. Thank you.